Hey, what are you discussing?
Actually, we are discussing about the operators. All these operators are very good to understand. But when it comes to the increment and decrement operator and bitwise operator, I feel very difficult to understand it. If anyone explain it, I would feel very easy to understand.
Don't worry, we will explain you.
Okay, thank you.
Hello everyone, this is Shashika and she is Madhumita. We are from CSC department. We are here to explain about increment, decrement and bitwise operators. Increment operator is used to increment the value of a variable by 1. Similarly, decrement operator is used to decrement the value of a variable by 1. Plus plus symbol used to represent increment. Minus minus symbol used to represent decrement. Post increment or decrement have high priority than pre-increment or decrement. Increment is of two types. Prefix increment, postfix increment. For prefix, it is plus plus x, and for postfix, it is x plus plus. In prefix, it first increment the value and then assigns the value. Coming to postfix increment, it first assigns the value and then increment the value. In decrement operators, there are of two types, prefix decrement and postfix decrement. Minus minus x, it first decrement the value and then assigns the value. Coming to postfix, x minus minus, it first assigns the value and then decrement the value. Let's see example. X is equals to a plus plus. Let us consider a is equals to 5. In step 1, x is equals to a. It first assigns the value. In step 2, a is equals to a plus 1. So it increments the value. So it becomes 6. X is equals to plus a. In step 1, it first a is equals to a plus 1. So it increments the value 6 and then assigns the value in step 2. In step 2, x is equals to a. So a becomes 6. Similarly, for decrement operators, x is equals to a minus minus. Let us consider a is equals to 5. In step 1, x is equals to a. It first assigns the value. So it becomes 5. In step 2, x is equals to a minus 1. It decrements the value by 1. So it becomes 4. Coming to x is equals to minus minus a. In step 1, a is equals to a minus 1. It becomes 4. In step 2, x is equals to a. So it becomes 4. Let us see the execution. Coming to execution part, a is equals to 5. Here x is equals to a plus plus. Now let's see the value of x and a. Let's see the output. Here x is equals to 5 and a is equals to 6. Coming to prefix expression, x is equals to plus plus a. The value of x and a are x is equals to 6, a is equals to 6. Let us combine both prefix and postfix increment in one expression. Here a is equals to 5. The expression is x is equals to a plus 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 a. Now let's see the value of x and a. Here the value of x is equals to 12 and the value of a is equals to 7.
Bitwise operators are used to perform the operations at the bit level. We have different types of bitwise operators in C, namely bitwise AND, bitwise OR, bitwise XOR, left shift and right shift. Coming to bitwise AND, it has a multiplicative property. Let us see the truth table. If two inputs are 0, then we'll get the output as 0. If two inputs are 1, then we'll get the output as 1. Let us see the truth table. If two inputs are 0, the output is also 0. If two inputs are 1, the output is 1. Let us take an example. The binary representation of 7 is 0, 1, 1, 1 and the binary representation of 4 is 0, 1, 0, 0. Let us perform AND operation by using the truth table. If both the inputs are high, the output is high. The binary value of 4 is this. Finally, when we perform the AND operation, 7 and 4 is equal to 4. The next is bitwise OR operator. It has the additive property. Let us see the truth table. If one of the input is high, then the output is also high. Let us take an example. The binary value of 7 is 0, 1, 1, 1 and the binary value of 4 is 0, 1, 0, 0. The output when the bitwise OR is applied, the value is 7 and the final output is also 7. Bitwise XOR. It takes two numbers and perform the XOR operation. Let us see the truth table. If both the inputs are the same, then we'll get 0, otherwise we'll get 1. Coming to the example, the binary representation of 7 is this and the binary representation of 4 is this. When we apply the XOR operation, we get the final value as 7 and the final output is also 7. Bitwise NOT. NOT is a unary operator. It takes only one number and performs the NOT operation. Let us see the truth table. If the input is 0, it is 1. If the input is 1, the output is 0. Let us see the example 7. The binary representation of 7 is 0, 1, 1, 1 and after applying the NOT operation, we'll get the output as this. Left shift operator. It shifts the number of bits to the left side. First operand. is the number and the second operand is the number of bits that should be shifted. Here is the example. B equal to A left shift 1. A is the first operand and 1 is the second operand. The binary representation of 10 is 1010 and the bits are shifted to the left and the empty space is filled with 0. The final output is 20. Right shift operator. It shifts the bits to the right side. First operand, right shift, second operand. First operand is the number and the second operand shifts the bits to the right side. Let us consider an example. A right shift 1. Let us consider A equal to 3. Where binary representation of 3 is that. Let us see how it works. The binary representation of 3 is 0011 and it shifts the bits to the right side and the empty space will be filled with 0 and the rightmost number is discarded. Finally, B is 1.
Hope you all understand this topic. Thank you.